force that allowed it to escape the gravity envelope of the Earth.
How can it follow the
You're
curvature of the
saying-
Earth when we are in a straight and level flight? Take the
You
Earth out of
don't
the
know
equation.
that, but you don't know that you're in a straight and level flight because you have nothing to measure it by.
I most certainly do. I can take a level. I can take a level and I can put it in the aircraft if I were so inclined to do so, and it would show me as level. Conversely, our artificial horizon shows us that we are in a straight and level.
How do you think a level works? It
I
works by gravity.
Yeah, Bob, get this. Somebody
It
told me
works by buoyancy. All
But
right.
Bob, get
Yes, right. And buoyancy is subject to gravity.
Somebody said if we take a 1 foot level and put them end to end to end to end, that they'll come back and meet. That's how the ball works. It's to think that way is crazy. If you
No,
think
it's
that you
not,
could
because the
put
level's
one
only
foot-
the level is a very short instrument. It's not going to detect any differences.
So
if
you're
you
saying
put one
if we just
level,
put one foot after another, 1 foot level, 1 foot level, 1 foot level, I will eventually meet end to end with where I started?
Yes, and doesn't that level also work based on the principle where that bubble is inside of a liquid? Because the liquid will always tend to seek level. Is that not true about water?
yeah, but if you tilt the level, why does the water go down? Because it's being pulled by gravity.
No, it's not gravity. It's acceleration. Whichever way you tilt it is the water's accelerating one direction and the air is going the other.
You know
Yeah,
what?
but the reason it's accelerating is it's being pulled by
Okay.
gravity.
Okay,
Gravity
Robert.
is acceleration.
Let's give you that one. Let's say that it is gravity that's doing that. Whether it's gravity or buoyancy or viscosity or whatever, the point is that in the airplane we are measured at a straight and level flight. Now, whether that level is acting that way due to gravitational forces, and of course it's more than that because we're using a gyroscope that was referenced from the ground as it sits there straight and level. It's calibrated before you take off, and that gyroscope is going to keep it at that exact same orientation no matter what. And
No,
when you're in
that
a
is
climb,
not the case. That gyroscope is going to function as a function against the curvature of the Earth and the gravity of the Earth as that curvature makes the gravity.
See,
No,
to us,
The gyroscope is not an independent machine. That gyroscope it works because it's in the envelope of the gravity of the Earth.
They don't use one in space?
Yes, they do. That's because the gravity of the Earth extends out into space.
They didn't use one at the moon?
Well, we're not talking about that right now.
Well, what I'm saying is you just said it's because it's in the envelope of the... What the problem
We're
is
talking
you just...
about a plane going from New York to California.
What I'm saying is that has to apply everywhere. You're saying that because you're in the pocket of Earth's atmosphere that the gyroscope operates a certain way. That would mean that if it's in a different area of Earth's atmosphere, it's going to operate a different way. You're just giving
the gyroscope will work anywhere.
Yes, if you're at an altitude of 50,000 feet, the gyroscope is going to work a little differently than it would be at 10,000 feet because the gravity envelope is stronger at 10,000 feet.
Gyroscopes work by inertia and mass. That's not changing, Robert.
What do you think inertia comes from?
Well, the inertia is coming from the spinning, the mass that's spinning around in circles.
Yeah, and what does that mass contain?
Ether?
No, I'm talking every mass that we know about has gravitational attraction. That's been measured in the laboratory. So there is no inertia without gravity. There is no gyroscope working unless it's in a connection with gravity.
Well, yeah. What was that experiment, Jaron, where the two balls supposedly attracted to each other? I mean, by your logic,
Cavendish.
You should be able to take a bowling ball and put BBs in orbit around it.
Yep.
Wait a minute. The two-ball experiment you're talking about was a theoretical Gedanken experiment. It was not an actual experiment.
But that's what they show in physics class to prove gravity in schools. Cavendish.
No, they don't. No, they are showing the anomalies that may occur if you have two balls in an empty universe.
And it's
That's
hung
all they
from
were
a
doing
string.
there. Look, if I drop my pen from my desk to the floor, if I drop it, it's going to fall. That is a fact.
Okay.
That's gravity. Okay?
Now you're applying that same force and saying it's going to lower the plane a perfect amount to keep it the perfect distance from the Earth. You're giving it like God qualities.
You know why I say that? Because I've seen planes fall from the sky and hit the Earth and crash. Okay, so I know that something is pulling that plane down.
Yeah, but that doesn't mean that it's going to pull it down an equal amount per the distance that it is. You're basically saying if we're 30,000 feet high, the plane knows how to stay exactly 30,000 feet high. That's how it gets to Hawaii and goes over a 789-mile curvature. We're saying...
What I'm saying is you have nothing else to measure against it. You're assuming that
Right.
plane is
So
going straight. You don't know that because you
You're right.
can't measure that plane going straight.
But
Well,
I
then
can
what are our instruments telling us?
That's what we're saying. And then
Your instruments are based on what the frequencies are, the signals that are bouncing off the Earth
No.
that go back up to the plane. What else do you have to measure it against?
the plane is just it's lift. The plane is flying.
Look.
It tells you it's height.
So are you bouncing it off the air then?
We're not
Bouncing what?
Bouncing what?
You're bouncing the signals so that you know where you are. They bounce the signals off the Earth so they can tell how far they are up in the sky.
I'm not talking about that type of navigation. I'm talking, let's go VFR. Let's get rid of all the instrumentation, save the artificial horizon, okay? So the artificial horizon with no other GPS, no other anything, is all that's really required is a level and a compass to navigate somewhere, okay, in an airplane. You don't need anything else. So we have the instrument, if we're in a cloud, for example, where our eyes would give us vertigo and we can't visually see and look off into the horizon, then we have to depend on that gyroscope or level or whatever.
We've already been through that, Bob. The compass depends on the magnetic field of the Earth, and the gyroscope depends on the gravity of the Earth as how it's going to function. So
Yes.
unless you're out in space somewhere where you don't have any inertial forces or gravitational forces, your plane is going to be subject to the forces that it's within. And it's within the gravity and the magnetic field of the Earth.
Yes, and the other force, of course, is the Bernoulli principle, which is keeping it lifted up into the air.
Yeah, but the Bernoulli principle is working against gravity. If you take
the Bernoulli principle is working against a pressure differential. It has nothing to do.
But the pressure differential is working against gravity so it can keep the plane in the air. It creates a vacuum to counteract the gravitational force on the plane.
But we're straying from the original point that we're talking about here in the first place, and that is that in a straight and level flight, by all indications...
You can't say it's a straight and level flight because you don't know it is. You have nothing to measure it against.
If you think of the sphere, and this is where I go back to just using your own mind. If you're talking about a plane leaving South America, a plane leaving Los Angeles, those two planes are starting to fly towards each other. They're literally flying belly to belly with one upside down, right? How else would you describe that? So you want us to believe that those planes are flying belly to belly, whereas we're saying we think those planes are flying on a flat, level plane, because that's how planes fly. So when you want us to believe in things going upside down and around to the side.
But see, they're not upside down, Jaron.
Explain why.
Just your perspective.
Okay, so here's my point. So if my perspective tells me I'm right side up right now, and somebody who's listening to this who might be in Australia, their perspective is telling them they're right side up. Well, if I think that other person exists in real life, then they're right side up. How could they be, their perspective is opposite of mine, unless I realize that we all live in the same world. We don't have, it's not our own individual little bubbles where we all get to walk around in our own perspective. I can't leave people on the street because they're hungry and just say, I'm not going to feed you because your perspective is you're hungry and my perspective is you're not. This is real life. You have to really see other people in this world. You can't just assign them make-believe crap so you get away with yours. That's not how the world works. You can't just say everyone is below my horizon, because then to them you're below their horizon, and that breaks the laws of reality. But that's what they do.
Jaron, let me ask you this: do you believe in gravity or not?
But it depends what you mean by gravity. Do I believe things will fall if you drop them at a speed until it hits the maximum speed of free fall? Yes. Okay,
so why can't the man in Australia stand on the land in Australia and be held there by gravity? What is so counterintuitive about that to you?
If you mean, and I'm on the opposite. I'm standing upright on the top of the globe.
Yeah.
Because that's not. Because what you're describing is a cartoon. You're saying that the middle.
Wait a minute. Why? Tell me why.
I'll tell you why.
Yeah, go ahead, Bob.
Okay, because here's the reason, Robert. Because gravity seems to be very selective in the way that it works. Because yes, if the gravity is actually holding you to the Earth, and it's powerful enough not only to hold you to the Earth, but to hold all the oceans to the Earth on the underside, then why is it that a butterfly can just simply fly away, and gravity doesn't have this massive same effect on it that it does to hold tons, megatons of ocean in? That's why.
Because the wings of a butterfly create an inertial force against gravity that allows it to fly. And you could say even the Bernoulli principle could be at work with a butterfly, because it's going to create a vacuum with its wings that's going to pull it up above. That Bernoulli principle makes it more powerful than gravity at that point in time.
Or it could be just like if we were in a swimming pool and we're swimming and we're flapping on our arms, and that's keeping us afloat. It's the same idea as this density and this buoyancy idea that replaces gravity in our model. Gravity is something, first of all, Newton, when he came up with his theory of gravity, admitted it was just that. It was a theory. And beyond that, he really didn't explain much more. There are things that we can observe that seem to fit those parameters of Newton's laws, but it just seems that...
No, I think you need to make distinctions here, Bob. What Newton said was that he couldn't tell us how gravity worked, but he could tell us the speed that gravity
from one
functions at when things fall.
Okay, and can they tell us how gravity works today, Robert?
No, they can't.
Well, then that's pure speculation, then, isn't it?
No, the fact is that when I drop my pen, it does fall to the floor.
Okay, so how is the ocean held to the floor, Robert? The ocean combined, Pacific Ocean, you're talking trillions of pounds.
It doesn't make any difference because there's gravity all over the surface of the Earth.
So how does it know how much to hold the water and how much to hold me?
Apparently it does. See, this is not going to prove anything for you.
Well, what you're doing is you're giving gravity godlike quantities.
No, I'm not. No, I am not at all.
Choosing? You're giving it powers to choose. You're saying that the same force that holds the entire ocean to the Earth is the same force that makes me stand on my feet on the Earth. You're giving them the same. Okay, but I'm saying, how does it know not to hold me with the same force that it would hold the ocean, or something of my same exact size but a heavier weight, or whatever it is? How does it know what to hold?
Because that's the way God made it. That's why objects fall at the same rate of speed, no matter how heavy they are.
Okay, so answer this then, Robert. If I'm standing on the side of the globe and I capitulate to the idea that gravity is holding me down from a perpendicular direction to what I'm standing, in other words, it's pulling me feet down, straight down.
Wait a minute, you don't know it's perpendicular because there's no measurement to make it perpendicular. All you know is you're standing on the Earth.
Okay, great. So I'm standing on the Earth and I'm standing on the side of the planet and it's pulling me down.
What do you mean the side of the planet? How do you know it's the side?
Because they can't have...
Okay, I'm at the equator. That's the side, yes? No? Yes? Am I wrong?
Well, that's in the middle of the planet, but how do you know it's the side?
Well,
see, that's what
we're getting at. The sphere has no sides.
See, and that's the problem here, because it doesn't matter where I am, because there's people all over the world. Right. Let's just say that if I am that person that's on the side and it's pulling me straight down, what's stopping me from falling over? If
falling over, what's going to pull you?
Well, gravity, apparently.
Gravity is a radial force. It's not a tangential force. There's nothing to pull you sideways.
So if gravity...
If there's something strange in your neighborhood, who you gonna call? If there's something weird and it don't look good, who you gonna call? That's right. I ain't afraid of no ghost.